In our study of chemical reactions, you know that in double replacement reactions, a precipitant is formed a lot of the times. And we've talked about how some compounds are soluble in water, while others may not be. These are going to look at the rules for solubility so you can make predictions about which compounds will form ions in solution and which ones will be precipitates. Now let's start off with just some review. When you see an ionic compound, that refers to the fact that a positive ion and a negative ion are bonded with an ionic bond. Usually that is a metal and a nonmetal from the periodic table, or it's a metal and a polyatomic ion from your reference tables. Now when we have an ionic compound, we write the symbol AQ beside it. That means it is soluble, or that it dissolves in water. Here are some examples. If we see the notation NaCl AQ, that means that the sodium chloride has dissolved in water and it forms one sodium plus 1 ion and one chloride negative 1 ion. Same thing for hydrochloric acid. With the AQ notation beside it, it means that that HCl molecule has dissociated and it's become H plus and Cl minus ions in solution. Polyatomic ions also do this. Sodium hydroxide dissolved in water will become sodium plus 1 and hydroxide minus 1 ions. Now think about this. How is the charge of those ions that I just showed you determined? I know you know there's a pattern where you can look on the periodic table, but why is the pattern there? Well, remember that elements need 8 valence electrons to have that full outer shell, or their octet. So the charge that they have is going to be reflecting what needs to happen so that they can obtain the 8 valence electrons. Elements gain or lose electrons to get that octet, and the number that they gain or lose determines their charge. Remember that when an element gains an electron, it becomes negative, and when an element loses an electron, it becomes positive. So look at these examples and let's see if we can figure out the ions and their charges. If we have fluorine and chlorine, each with 7 valence electrons, what's going to happen when they have a charge? Well, I know that each one of those elements is looking for 8 valence electrons, so they're going to have to gain one more to get that octet. If an element gains one negative electron, it'll have a -1 charge. So the fluorine is going to become F-1 fluoride, and chlorine will become Cl-1 chloride. Here's another one. Calcium starts with 2 valence electrons because it's in group 2. So when it needs to get its octet, it can gain 6 or lose the 2 that it already has. It's going to do the method that's easier, which is losing 2. When it loses 2, the shell up underneath will become the outer shell and it'll be full. So that's what calcium does. And when any element loses 2 negative electrons, its charge becomes +2. Alright, so now let's practice with a couple of these. Write the ions that form for this compound, Na2CO3. Well, when I look at the formula, it's made up of 2 sodium atoms and 1 carbonate polyatomic ion. So what happens is each one of the sodiums loses their 1 electron to become 2 sodium plus 1 ions, and there's 1 carbonate ion, and in your reference table the charge of carbonate is -2. There are 3 ions total here, the 2 sodium ions and the 1 carbonate polyatomic ion. Here's another one. Let's write the ions for calcium phosphate and then cadmium nitrate. Alright, so calcium phosphate first. There are 3 calciums and 2 phosphates. Calcium's in group 2 on the periodic table, so I think it's going to lose 2 electrons. And phosphate I can look up in the in the reference tables, and it has a -3 charge. So 3 calcium plus 2 ions and 2 phosphate -3 ions is what you get for that first one. Now for the cadmium nitrate, I have 1 cadmium and 2 nitrates. Cadmium is a transition element, so it's going to be a +2 ion. And nitrate, if you look that up in your reference packet, is a -1 ion. So for this compound in water, there's 1 cadmium +2 and 2 nitrates with a -1 charge each. Alright, let's try one more. Here I've got Na2S and then Mg3BO32. Alright, so for Na2S, I've got 2 sodium ions and 1 sulfide ion is what I'm going to form. Sodium is in group 1, so it's going to lose 1 valence electron. That'll be 2 sodium +1 ions. And sulfur is in group 16. It's going to gain the 2 electrons, and that'll be S -2. So there's a total of 3 ions there. And then for the last compound, there's 3 magnesiums, so there will be 3 magnesium ions and 2 borate ions. Now each magnesium is in group 2, so it needs to lose 2 electrons. That'll be 3 magnesium ions with a +2 charge, and the borate ion is BO3 with a -3 charge. And there are 2 of those in this compound. So that's how you figure out the ions, and when a compound dissolves in water, this is really what's happening to it. Now here's a picture of the solubility rules that are in your reference packet. The way that you're going to use these is to help you determine if a compound is going to have the aqueous notation beside it, or if it's not going to be soluble, we're going to call that a precipitate, and we're going to put the small s notation beside it for solid. You're going to use the solubility rules with the last part of the compound's name. So when you look at these, there's a soluble list on the left and an insoluble list on the right. Now be careful reading them. There are some exceptions that you're going to run into. Alright, so here's the table that's in your notes. What I want you to do is use these compounds and the solubility rules, and I want you to figure out which ones are insoluble. Now I'll do the one in the top left with you just as an example. This is magnesium fluoride. So if I go back to the solubility rules, there is a rule on the left-hand side that says all fluorides are soluble except group 2 fluorides, lead 2 fluoride, and iron 3 fluoride. Now I don't have lead or iron, but I do have magnesium fluoride, which is a group 2 element. So this compound is not going to be soluble. It is insoluble. So I would put a circle around the magnesium fluoride. Now I want you to try the rest, and we'll check on your progress next time we're together. Thanks!